Mini light emitting diode, mini LED. Think of mini light emitting diode, or mini LED, as the ultimate evolution of the traditional LCD screen. For the last 20 years, LCD screens have used a backlight, a single, large panel of lights, to illuminate the image. Mini LED takes that bulky backlight and shrinks it down to a microscopic scale. It is the bridge between the old world of standard LCDs and the futuristic world of OLED. For your CompTIA A+ exam, and as you build out your home lab, you must understand how this technology solves the contrast problem of standard screens while avoiding the burn-in risks of organic displays. The architecture, tens of thousands of lights. To understand mini LED, you have to look at the backlight sandwich we discussed earlier. In a standard LCD, there might only be a few dozen LEDs at the edges of the screen providing light. In a mini LED display, the provider replaces those few large bulbs with tens of thousands of microscopic LEDs packed tightly across the entire back of the panel. Because these lights are so small, usually less than 200 microns wide, the manufacturer can pack a massive number of them into the same space. The major advantage: local dimming zones. The superpower of mini LED is a feature called local dimming. Remember how we said IPS panels struggle with blacks because the light from the back leaks through the shutters. Mini LED fixes this by grouping those thousands of tiny lights into hundreds or even thousands of independent dimming zones. If you are watching a movie and one part of the screen is pitch black, the computer can physically turn off the specific mini LEDs behind that black area. Meanwhile, the part of the screen showing a bright explosion stays illuminated at maximum strength. This allows a mini LED screen to mimic the perfect blacks of an OLED while maintaining the incredible brightness and color accuracy of a high-end LCD. High dynamic range, HDR performance. Because mini LED can get incredibly bright, often 2 or 3 times brighter than a standard OLED, it is the king of HDR, or high dynamic range. In your cybersecurity work, if you are looking at detailed satellite imagery or complex data visualizations, you need a screen that can show extreme highlights and deep shadows simultaneously. Mini LED provides the punch and brightness needed to make high-contrast images look lifelike, even in a brightly lit room like your kitchen or a sunlit office. The contrast: mini LED versus OLED. As a technician, you must be able to contrast these two premium technologies for a client. Longevity: unlike OLED, which is made of organic material that decays over time, mini LED is made of traditional inorganic materials. There is zero risk of permanent image burn-in. You can leave a static monitoring dashboard on a mini LED screen for 5 years, and it will never leave a ghost image. Brightness: mini LED can reach much higher peak brightness than OLED. If you are working in a room with a lot of windows, mini LED is the better choice. The blooming effect: while mini LED is great, it isn't perfect, because it still relies on zones. Sometimes a small bright object, like a white mouse cursor, on a black background will have a faint halo or glow around it because the dimming zone is slightly larger than the object. OLED, which turns off every individual pixel, does not have this problem. Final comparison for the technician. When you are out in the field, remember these quick profiles for mini LED. The best part: incredible brightness, great contrast, and no burn-in. The worst part: it is still thicker and heavier than OLED, and high-end models are very expensive. The use case: high-end professional laptops, creative workstations, and users who want great contrast but need the monitor to stay on for 12 hours a day with static images.